Hello, welcome back once again. Today we have another interesting integral from JEE Advanced math problems. We have to integrate from 0 to 1 the sine of natural log of x divided by the natural log of x dx. Now let's see how we're going to evaluate this integral. But we're going to use the Feynman's techniques, okay? Or the Feynman's trick. So let's start with the following. Let's call it I. Now we're going to make the following substitution. We're going to let the natural log of x equals negative t. If you solve for x, x is equal to e raised to the power of negative t. Differentiate both sides, we get dx is equal to negative e raised to the power of negative t dt. Therefore, our I is going to be equal to the integral. Now let's think about the limits. If x is approaching, remember from this equation here, t is equal to negative natural log of x. So if x is approaching 0, t will be approaching negative natural log of 0, which is infinity, positive infinity. Then if if x is approaching 0, if x is approaching 1, t is approaching 0. We have here the sine of negative t divided by, here we have negative t, multiplied by, this will be negative e raised to the power of negative t, and then dt. So from here, remember the sine function is an odd function, right? So we have I is equal to the integral. If we switch this limit from 0 to infinity, then we're going to cancel this negative sign. Then don't forget this is negative sine of t divided by negative t multiplied by e raised to the power of negative t, and then dt. With this nice cancellation here, our integral is transferred to integral from 0 to infinity. This sine multiplied by e raised to the power of negative t whole divided by t, and then we have our dt. Now from here, we're going to make use of the Feynman's technique. So let's define a function, and what's that? That I of a is equal to the integral from 0 to infinity sine times e raised to the power of negative at, then divided by t dt. And obviously we know that this our integral here is equal to I of 1, right? Okay, now we know I of 0. Let's find I of 0. That would be very nice. So I of 0 is going to be equal to the integral from 0 to infinity sine of t e raised to the power of 0, right? Then divided by t dt, which is giving us the Dirichlet integral, right? This is known as the Dirichlet. Oh, did I pronounce it well? I think it is Dirichlet integral, right? Then divided by t dt, which is equal to, well known, pi by 2, right? So this is I of 0. Okay, that is cool. We have here I of a is equal to the integral from 0 to infinity sine times e raised to the power of negative at divided by t, and then dt. Now we're going to differentiate with respect to a. At the left hand side, it will be I sub a. Oh, not sub a, I mean I prime of a is going to be equal to, we're going to partially differentiate the right hand side with respect to a, the integral from 0 to infinity sine times e raised to the power of negative at divided by t, and then dt, which is equal to the integral from 0 to infinity. We have our sine divided by t. Then we partially differentiate with respect to a of e raised to the power of negative at, and then dt. So here we get I prime of a is going to be equal to the integral from 0 to infinity. We have here sine divided by t multiplied by, that will give us negative t, then times e raised to the power of negative at, and then the t, of which you can see this nice cancellation going on here. This is equal to negative integral from 0 to infinity sin times e raised to the power of negative at dt. And that is easy from here, right? We can use the integration by parts, but in this case, I'm going to make use of exponentiations, okay? So here, we're going to say I prime of a is equal to negative the imaginary part of the integral from 0 to infinity. Here, this is going to be I raised to the power of it. The imaginary part of e raised to the power of it is sine of t. Okay, don't forget that. Then multiply e raised to the power of negative at dt. And from the law of algebra, we know what is going to happen. The same base, we're going to add the exponents. We get e raised to the power of it plus minus at is same as negative at here. And then the t. At the numerator, at the power there, we're going to factor out negative t. So I prime of a is equal to negative the imaginary part of the integral from 0 to infinity. So this is going to be e raised to the power of negative t. And then we're going to have, that will give us a minus I. And then we have already t. Now time for substitution. We're going to let t into bracket a minus I equals x. Now if you divide both sides by a minus I, we see that t is equal to x divided by a minus I. Differentiate both sides, we get dt is equal to dx divided by a minus I. Therefore, I prime of a is going to be equal to negative the imaginary part of integral. Remember, the limit remains the same. From 0 to infinity is going to be e raised to the power of negative x. The t is equal to dx divided by a minus I. So from here, I prime of a is equal to, this will be negative 1 all over a minus I, the imaginary part, the integral from 0 to infinity. Here, this is e raised to the power of negative x multiplied by 1 is same as x raised to the power of 1 minus 1. And then we have a dx. Okay, the reason for this is we're going to make use of the gamma function. Remember, the gamma of n is equal to the integral from 0 to infinity e raised to the power of negative x times x raised to the power of n minus 1 and then dx. So with the help of this integral is equal to negative 1 over a minus I, then the imaginary part. This is going to be the gamma of 1. Gamma of 1 is equal to 0 factorial, which is 1. Therefore, we have our I prime of a is equal to the imaginary part of negative 1 all over a minus I. So this is going to be equal to the imaginary part. Now we rationalize, right? So this is going to be negative 1 into bracket a plus I divided by a minus I multiplied by a plus I. So from here, I prime of a is going to be equal to the imaginary part. So up there we have negative a, negative I. Down here, difference of two squares, it is going to be a squared minus I squared. I squared is negative 1. This will give us plus 1 here. Now, the imaginary part of this is equal to negative 1 all over a squared plus 1. It is clear enough, right? Therefore, our I prime of a is equal to negative 1 divided by a squared plus 1. Now, we're going to integrate both sides with respect to a. If you integrate the left-hand side, we need to integrate the right-hand side. So for the left-hand side, that will give us just a, I of a, So this is going to be equal to negative integral of 1 over a squared plus 1 dA, which is going to give us negative inverse tangent of a plus c. Okay, so therefore here we have I of a is equal to the negative inverse tangent of a plus c. Now let a equal 0. Remember I of 0 is equal to pi by 2. So this is also equal to negative inverse tangent of 0 plus c. We know the inverse tangent of 0 is 0, right? Therefore, we see that pi over 2 is equal to c. That is cool. Therefore, our I of a is equal to the negative inverse tangent of a and then plus pi by 2. Now remember that a must be equal to 1 for us to get the solution to the integral. Therefore, we see that I of 1 is equal to negative inverse tangent of 1 plus pi by 2, giving us negative pi by 4 plus pi by 2, and that will give us positive pi by 4. So therefore, we can say that our integral from 0 to 1 of sine of natural log of x divided by the natural log of x dx is equal to pi all over 4. This is cool. If you really enjoyed this video, kindly support this channel by subscribing. Also like, comment, and share.